All right, so we're starting our new unit, which is about systems of linear equations. Systems of linear equations. The first thing I want to tell you is just what that means. Basically, a system is when we have more than one line. So like in this example right here, more than one line on a graph. Straight lines, that's what the linear part means. So the last unit we spent all the unit talking about, like, if you had an equation, you know how to graph it, you know what it means, stuff like that. This unit, we're talking about when you have two lines and we want to find that spot where they intersect, the POI, the point of intersection. For example, let's say we have two situations. We have x is time and y is distance. So this is hours and this is kilometers, whatever. So we'll have one person start, let's say like a kilometer away from home, and he walks like a constant speed of 1 kilometer per hour. So that's red dude's path. Blue guy, he starts, let's say 5 kilometers there. Let's make him like 6. 7. And he'll go back towards home 2 kilometers per hour like that. Cool. So what we'll notice is that after we graph the two lines, there is a point of intersection. This point of intersection is really important because it's the solution is what we want to find, but we also have to understand what it means in the context of the question. So basically what it means is that at that point, at 2 hours, both people are 3 kilometers away from the starting point, which means that's where they like meet. Different word problems will mean different things based on what the question is, but that point of intersection is always where the x and the y value are the same, which means that usually the two lines, like either people are meeting or the situation's the same. That's what we always want to find. So we need to be able to figure out how to find them, but before that we also need to figure out how many POIs there are. In this example there was obviously one. It was that one right in the middle, but there's other situations. So for example, this is what most of them will be. There'll be one solution. That's where you have two lines and they just cross. There will be some situations where there's no solution. As we can see by these two lines, they're parallel, which we did last unit, which means they have the same slope. They're never going to cross each other, which is like if two people were walking, they're going the same speed, so they're never going to catch up to each other. There's also this third one, which is kind of cheesy. The idea is that there's like two lines overlapped, that they're exactly the same. So it's two people started at the same point and walk the same speed, which means they're next to each other the entire time. So it has infinite number of solutions. Remember, a solution is a POI. Is infinite number because at every single second of every single point, they are at the same distance and the same amount of time has passed. So there's an infinite number of solutions. Those are the three types and most of them are going to be this first one where there's one solution. There's 3 ways we can solve and find the point of intersection. We can either use substitution, next video, elimination, video after that, or we can graph it. That's why we needed to learn how to graph in the last unit so we could solve these questions. We're going to talk about graphing first. It's the easiest method, but it's also inaccurate. So for example, if we were to graph it, those 2 points like that point of intersection is there. I can see it when I graph it, but it's hard to see exactly what it is. So graphing is the least accurate, but it's also the easiest. So let's try graphing these 2 equations. So most questions are going to give you 2 equations, and they're going to say, find the POI, or find the solution to these 2. So I'm going to graph them. Let's call this, the first one will be the red line. So I start at -4, and it increases by 2 every time because of the slope. So I'll put a bunch of points. Cool. Connect them with a line. That's not straight, but whatever. And then I will make the second one, the green equation. It starts at 1, and it goes up by 1 every time. Bam, right there they touch. Okay. So the question said find the point of intersection. Literally for graphing, you just look at the picture and it's there. So I'm going to put my XY coordinate. Every point of intersection is always going to be an XY value. So you need to put a coordinate. So if you find out like, oh, X is 3, you're not done. You need to know what Y is as well. So in our situation, the point is for X it's 5 and for Y it's 6. 5, 6. So that is the point of intersection. At 5x, they will have the same y value, which will be 6. And that's it. So when we get these equations, these systems, which are 2 lines in one graph, we want to find the point of intersection. We can just graph it. We know that this graph is going to have a point of intersection because the slopes were different and they're not exactly the same. Oh, actually, really quick, let's look over this one more time. infinite number of solutions. So for example, let's say like y equals 3x plus 4. The one that would be the exact same as that would be something like this. Plus 8. So that would be where like you doubled everything in the equation. It's the exact same. So if we reduce this, if we simplified it, it would become y equals 3x plus 4, which is the same equation, which is like the two people are going the same speed and starting at the same point. And that's when you would have infinite number of solutions. And that's it.